Hey, this video is about the next problem set, Module 2 problem set. It's translations, reflections, rotations, and symmetry. For this first week, we're just going to cover the translations and the reflections. So next week we'll do the rotations and symmetry. So let's get into it here. This says translate the given figure by the given vector and describe the vector in vector notation and write an algebraic rule describing the translation. So a bunch of vocabulary there. A vector, so this arrow here that they called V is a vector. The notation is actually pretty simple. So this vector, V with a little arrow on top, notice how it goes starting here and going to the arrow. You have to go right 4 and up 2. So the way you write that is 4, 2. So 4 is the distance you go in the x direction, and 2 is the distance you go in the y direction. And that's all there is to it. And there's these little pointy parentheses you use when describing a vector. Okay, so how do you use that? Well, this is a nice, concise way of describing how to translate something. Now, translation is just a fancy word for sliding it. So every point on this triangle is going to slide over 4 and up 2. So let's do it point by point. Point A is going to go over 4, up 2. So we'd say this is the image of A, or A prime. Point B is going to go over 4, up 2. There's B prime. C goes over 4, up 2. There's C prime. And then we just connect the vertices, and we've got the image. So there you go. There's the translated figure. Notice it's the exact same shape. It's just it's been pushed to the right and up. Right 4 and up 2. And then for the algebraic rule describing the translation, you would just say every point xy, so every xy pair got mapped to x plus 4, y plus 2. So that's carrying over from our last problem set. So every point's x value got increased by 4, and every point's y value got increased by 2. Let's do one more together, and then we'll move on. So like this shape. Let's see, where are we going? We're going left 3 and then up 5. So the way you write that vector would be, this is the, maybe one of the trickier parts is if you're going left, that's like the negative x direction. So you'd say negative 3 and then positive 5. Let's go point by point. So take point B, left 3, up 5, 9. C, let's go left 3, up 5, 9. A is left 3, 5, and B is left 3, up 5. Notice, I mean, I could do them in alphabetical order, but I don't have to. There's no reason to do them in alphabetical order. No, any order you like. Again, notice every side, like DC, used to be 4 units long, and its image, D prime C prime, is also 4 units long. So this is what they call a rigid transformation. So this is a rigid transformation. Okay, so anyway, the vector is negative 3, 5, and then what's the algebraic rule? Well, all my xy pairs got mapped. In this case, we subtracted 3 from the x. So x minus 3, and the y had 5 added to it. So there we go. So there's the, we translated the figure, we wrote the vector in vector notation, and then we wrote an algebraic rule describing the translation. So we fulfilled all the instructions. Okay, so you got to do C and D on your own. I hope that was a good enough guide for you. Same thing with number 2 is just additional practice with that. So it's just to make sure you understand how the notation works and stuff like that. So as always, feel free to email me or contact me if you are stuck or confused. So what else? Then there's just some kind of word problems. So like number 3 says, find the image of this point, negative 16, 22, after being translated by this vector. Now those are some big numbers, so I'm not going to draw a picture of that. I just need to think algebraically. So think about, what does this vector do? The vector 4, 10 is going to go over 4 up 10. So I'm just going to add 4 to that. So add 4 to my negative 16, and I'm going to add 10 to my 22, and that's going to give me the image negative 12, 32. So my answer to this question would be that. So when you see a vector like that, you can think of this as a way of saying every point that undergoes this translation is going to have 4 added to the x and 10 added to the y. For 4, it's kind of the reverse. It's like saying, well, I know where I started and I know where I ended up. So what was the vector that caused this transformation? What kind of vector would get me from 9 to 4, and what kind of vector gets me from 7 to 15? So if you apply the same idea, you're basically saying, 9 plus what would have given me 4? Well, if you solve this, you get negative 5. So that was for the x values, the 9 and the 4. How about for the y values? Well, 7 plus what would give me 15? The answer to that is 8. So the answer to this question is that my vector v is negative 5, 8. That's all we had to do. Sorry. Okay, number 5. I'll just give you a hint on this one. It's about length, and that's what we've been talking about. That was a big part of our first problem set, length. So, when you take a point Q, and then the vector that maps Q to Q prime is 8, 4. So if you go over 8 up 4 to get to Q prime, so there's my mapping, Q to Q prime. What's the distance? What's the length of that segment? Well, you should use the Pythagorean theorem there to find the length. So, you're going to go 8 squared plus 4 squared equals length squared, and do a little bit of calculation. All right. So just to clarify, we're not done with this problem yet. So please don't turn it in with just this. You got to actually find the length. You got to find out how big is that number. It's going to have a square root involved in your final answer. Okay, so now for 6, you just need to go and think what kind of vector would shift something just left 3 units. So if you think back to the first few problems we did, with these, so the vector 4, 2 shifted us right 4 up 2. The vector negative 3, 5 shifted us left 3 up 5. So what if we wanted to just go left 3 units? Well, all that would be negative 3 in the x direction and then nothing in the y direction. So you can have 0 as one of your coordinates. How about sliding down 7 units? Well, to go straight down, you don't need any change in the x direction. So no change in the x direction. And then down means you want to go negative 7 in the y direction. So then try to figure out the rest of these. What does it mean to slide up? So up, is going to be a y value change. We're going to be adding 5 to the y value. Sliding down 2 would be, again, that's y values. And then these are combinations. So how about going left 4 up 9? Or how about going right 8 down 1? Again, you can reference the first 2 examples we did to get some hints on those. Okay, so then number 7, let's do 7 together. You got a video game sprite is at point A, and it travels along a vector v1 to get to point B. So I'm going to draw that in here. That's the vector v1. And then it travels along vector v2 to go from point B to point C. So here's his journey. He travels along vector v1, then he travels along vector v2. So what are these vectors? So let's look at vector v1. How do we write that? Well, we are going over 1, 2, 3, 4, 5, 6, 7, and then up 2. So vector v1 was over 7, up 2. How about vector v2? Well, vector v2 went left 4, up 3. So left 4, up 3. Now the question asks us, after we have those, find a vector v3 that would have translated the sprite directly from point A to point C. So let's look at this vector. I'm not sure why I'm drawing it as a dashed line, but I don't know. Seems fine. Doesn't have to be a dashed line. So there's v3. So let's look at v3. Well, v3 is over 3 up 5. So as you can see, to get from A to C directly, we could have just gone over 3 up 5. Now the question's asking, what is the relationship between the vectors? Well, do you notice something going on here with the x values? 7 plus negative 4 is 3. How about the y values? 2 plus 3 makes 5. So what this shows is that if you travel along two vectors, you can basically just add up the x coordinates to get the net result for the x, and you can add up the y coordinates to get the net result for the y. So in concise language, it's you would just say v1 plus v2 equals v3. So that's a mathematical statement relating the fact that 7 plus negative 4 is 3, and 2 plus 3 is 5. So that's how we write that. Okay. There's going to be a decent amount of practice with, or at least four practice problems where we are given the picture, the pre-image and the image, and we got to figure out what's the vector associated with each translation, and what's the algebraic rule. So I'll just do one for you. These should be fairly straightforward. So how did I get from A to A prime? Let's see. Let's draw the vector. Here's my vector. Let's see. It looks like I'm going over 1, 2, 3, 4, 5, and up 1, 2, 3. So this vector was over 5, up 3. The algebraic rule was every xy point mapped to x plus 5, y plus 3. That's all you got to do for this question. Now maybe you're wondering, wait, what about b and c? Well, okay, sure, we can do them all if you want. From b to b prime is over 5 up 3. This is sort of the key feature of a translation. How about c to c prime? Again, over 5 up 3. So we can see it. It's the exact same vector movement every single time. So there you go. I hope that makes sense. That's all you got to do for your answer. Draw the vector in. Draw it at least once. You don't have to draw all three of them, but it certainly helps make sure that you're not making any mistakes. So they should all be the exact same movement, over 5 up 3. Okay, so let's move on. Next is reflections and perpendicular bisectors. So number 9 says, for each reflection, take the point 3, 1 and reflect it under that reflection. And then make a conjecture about the general algebraic rule for that transformation. So it's a lot of jargon there, I guess, but all it means is take the point 3, 1. So on my xy axis here, I go over 3 up 1. That's my point. And it says reflect over the x-axis. So which one's the x-axis? This flat one is the x-axis. So let's reflect over that. Imagine this is a mirror. The point is going to land here. Okay? So let's say I'm calling this point, I don't know, A. This would be A, and this would be A prime. Okay? So that's all we had to do is reflect over that line. How about over the y-axis? Again, I start with the point 3, 1. Call that point A. But this time I'm reflecting over the y-axis. So I got to reflect over that. So now A prime would be there. Notice the distance involved. This time it was actually pretty close because he was close to the motion sensor again. Got me. Sorry. So reflect over the y-axis involved actually a longer distance of movement because he was farther away from the line of reflection. So moving on. Don't worry, we're going to come back and do the general rules in a second. We're first just doing the easy part. Reflect over the line y equals x. What's the line y equals x? Well, that is this line. It's the line. Every point that lives in this line is like points like 1, 1, 2, 2, 3, 3. It's every point that has the x value and the y value equal to each other. If you're thinking about it like y equals mx plus b, this would be a y equals 1x plus 0, so a slope of 1 and a y-intercept of 0. So however you think about it, this is the line y equals x. So let's take the point 3, 1 again. All right, now imagine reflecting over this line. So you're going to jump over the line. I hope this is sort of intuitive here. It would be like that. Okay. Hopefully the grid lines will help you see that. Okay. And then the line y equals negative x would be like this. Again, it's points like 2, negative 2, 3, negative 3, negative 2, positive 2. Anytime where the x value is the opposite of the y value. Again, I take the point 3, 1. I reflect them over. This one's a little bit tricky, but look to be perpendicular. This reflection line, I got to kind of go over 2, over 2, down 2, and then do that again. A ruler can be kind of helpful if you're getting stuck and need to like use the grid. But anyway, there's my reflection point. So notice it jumped over the line. So, all right, let's go back and figure out the general rules. On this first one, do you see how we went from, so we were at 3, 1, and we ended up at 3, negative 1. So we went from 3, 1 to 3, negative 1. That suggests that the rule is xy maps to, notice the x value stayed the same, and the y value got made opposite. So xy maps to x negative 1. All right, likewise, in this one, reflection over the y-axis, we had 3, 1 map to negative 3, 1. And so that means, that suggests that the rule is xy maps to negative x, y. So this time the x value got flipped, and the y value stayed the same. How about this one? Oops, sorry. This one's a little tricky. I used to be at 3, 1, and I mapped to the point 1, 3. So that's like saying x, y. So what happened here? How do you summarize that? Well, the x and the y swapped each other. So x, y maps to y, x. Lastly, the point 3, 1 mapped to the point negative 1, negative 3. That one's really weird, right? It swapped the x and the y, but also made them both opposite. So we can say xy maps to negative y, negative x. So those are this page is kind of, summarizes, these are the 4 most common reflections you'll see. And these are the 4 rules that govern those reflections. So those would be worth taking some time to make sure you understand them. because they're going to come up a lot. Okay, so next thing is perpendicular bisectors. So what does this have to do with perpendicular bisectors? Well, let's just follow the instructions here. So it says line H is the perpendicular bisector of segment AB. So what does that mean? Well, what that means is if I have a segment A, B, there's a perpendicular bisector. So let's look at that word, perpendicular bisector. Perpendicular means they cross at a 90-degree angle, and bisector means it chops the segment in half. So there's me chopping it in half, and here's the line H. So the line was named H. Okay, so perpendicular I can represent with that little symbol. And it also says that the line, the perpendicular bisector, intersects AB at the point M. Now the point M, it's named that way because M is the midpoint. So we drew a diagram, and we can get one more label in this diagram, because how do I tell the person looking at the diagram that M is in the middle of AB? Well, I can do this. Those little markings tell us that AM and BM are the same size. Okay? Now, as far as mathematical statements go, I can say things that like line H is perpendicular to segment AB. That little symbol means perpendicular. So this says line H is perpendicular to AB. I can say something like the length AM is equal to the length BM. Another statement I can say. And I can say something like, this angle here is 90 degrees. So now we have a pretty complete diagram explaining what a perpendicular bisector is. Next, complete the statement below. For every point P that lies on the line H, so imagine there's some point P out here, wherever you want to put them. Okay, here's a point P. What's true? Well, it might not be obvious from looking at the diagram, but it turns out that P is actually the same distance from A and B. There's a nice symmetry there. Maybe if I turn the paper, you can see there's a very nice symmetry that exists there. So I can say that for every point P that lies in the line H, the distance from P to A is equal to the distance from P to B. I know there's a lot of like symbols and stuff there. It could be a little confusing. Really, all we're trying to say is that when you have a perpendicular bisector, every point on that perpendicular bisector is the same distance from the endpoints of your segment. Okay, so moving on here. Consider the reflection of a triangle ABC over some line K onto its image A prime, B prime, C prime. This little symbol here is just a triangle. It means that ABC is a triangle, as it says here. So let's draw a picture of this. So say you had a triangle A, B, C, and then you reflected over. Here's us including a diagram with our answer. Imagine reflecting that over the line. So C would go to C prime. Just try your best to draw a decent diagram. It doesn't have to be perfect. So there's it reflected over. It says, what is the relationship between the line K, so this is the line K, and the segments A to A prime, B to B prime, and C to C prime? So look at those segments there. So based on the question we just did, we can make some kind of conclusion here that, well, it seems like there's a perpendicular bisector idea going on here. So the relationship between line K and these segments, again, B, B prime, A prime, and C, C prime, is that K, so line K, is the perpendicular bisector of the segment A prime, the segment B, B prime, and the segment C, C prime. So there's my mathematical sentence there. Line K is the perpendicular bisector of all three of those segments. Okay. All right, I hope that makes sense. It's not the easiest thing in the world. There's a lot of symbols, and it can get a little tricky. But anyway, for number 12, a little bit of algebra review here. So you'll see questions like this from time to time in geometry, where it's kind of a geometry question, it's kind of an algebra question, so it's kind of a mix of both. So it says that line L, is the perpendicular bisector of JK, solve for x and y. So the first thing we might notice is, hey, wait a second, this is describing an angle. Okay. Now, how big are the angles when two things are perpendicular? Well, perpendicular means 90 degrees, right? So I can write that this expression, this 3y minus 30 degrees, must be equal to 90. Okay, so you're going to solve that, dot, dot, dot. I'll leave that for you to solve. A little bit of algebra. So you'll get a y value. Now, what else do we have to do? Well, it's saying that Jm, this length, is 2x plus 4, and this length here, from m to k, is 4x minus 6. Again, perpendicular bisector means that Jm and mk are the same size, so I can write 2x plus 4 equals 4x minus 6. And again, I'll leave that one for you to solve. This one's a little bit more challenging because it has x's on both sides. But as always, you can feel free to contact me if you get stuck or you find this confusing and you need help. But, yeah. So solve for y, then solve for x. All right. Next, we've got a little bit of slope and midpoints combining with this stuff. So here's the segment AB with 2, 5. 2, 5 is up there. There's A. And then 4, negative 1 is down here. It's B. And it says find the slope and midpoint of the segment. So let's draw the segment in. If you draw it carefully, you might just see the midpoint. Remember, the midpoint is just halfway. How do you find midpoint just with the numbers? Well, you just go average of 2 and 4. So you go 2 plus 4 divided by 2. So that's 6 divided by 2, which is 3. And then you go 5 plus negative 1 divided by 2. The average of 5 and negative 1 is 2. And so what that tells you is that the midpoint is at 3, 2. And hey, hopefully we can see that. 3, 2, that's exactly where my dot ended up when I just drew it carefully on the grid. Let's get the slope next. How do you find slope? Well, a little bit of review for you here. Slope is rise over run. Probably learned about that a bit in your algebra class. So let's do the rise over run here. So how much rise and how much run is there between A and B? So you got to get from A to B, you got to go down 6 and then over 2. So the slope is negative 6 over 2. which is negative 3. Okay, so we just found the slope of AB. And now it says the last thing we got to do is find the equation of the perpendicular bisector. All right? So, well, what does that mean? Well, the perpendicular bisector is perpendicular to this line, to this segment. Sorry. So this is where it gets a little tricky. You might go, wait, how do I know what the slope is of my perpendicular bisector? Well, there's this idea of something called an opposite reciprocal, which means opposite means you multiply it by -1, and reciprocal means you effectively flip it over. It's a fraction, or technically it's 1 divided by the number. So long story short, the opposite reciprocal of -3 is positive 1/3. Now watch what happens if I draw in okay? So I drew in this to make it perpendicular. So what's the equation of this line? Well, the slope is 1/3, and we can see by counting squares that it crosses the y-axis at 1. And so if we use y equals mx plus b, you get y equals 1/3 x plus 1. So there's my perpendicular bisector equation. That was that. There's my slope of AB, and there's my midpoint of AB. So that was, that's a pretty involved problem. It had 3 major steps. So I'd like you guys to try on your own to do 14. It might take a couple minutes. And yeah, so it's the same exact process. You draw the 2 points, you find the midpoint, so average the x's, average the y's to get the midpoint. Do rise over run to get the slope, and then draw that perpendicular bisector in, and then use y equals mx plus b idea to figure out the equation. Okay, so next, 15 is going to use point slope form, which is a way to write the equation of a line. So I'll show you what I mean here. These are actually easier than they look once you get the hang of it. So you may or may not need to Google point slope form. I'm going to explain it here, but in case my explanation is too short or something, you might need to go and maybe find an additional resource I don't know, I guess just get more information on it. But anyway, so using point slope form looks like this. So first, it's the same kind of question. You go, to get the perpendicular bisector, I need to know the slope of this, and I need to know the midpoint. So let's do the midpoint first. Midpoint. What's the average of -3 and 5? Oh, -3 plus 5 divided by 2. What's the average of 12 and 2? 12 plus 2 over 2. So my midpoint is 1, 7. Okay. What's my slope? Rise over run. So I can use subtraction here. So how much rise is there? I can just go 2 minus 12. That's the rise. And the run is 5 minus -3. So here on top I get -10. On the bottom I get 8. That simplifies to -5/4. And so now, so my perpendicular bisector would have opposite reciprocal slope. And then I'm going to use point slope form. So what point slope form says is that you can write y minus y1 equals slope times x minus x1. Now, might look a little confusing, but x1 and y1 just represent a point, any point that you know is on your line. So here, what I'd have is y minus my point, 7. Sorry, the y value of my point. So 7 is like my y1 here. And then equals, again, I'm looking for the perpendicular bisector, so I'm doing opposite reciprocal slope, so positive 4/5. And then x minus 1. So there we go. That's my equation. Okay. Okay, so that's a bit of a doozy. Just try your best on B. It's not the most super duper critical thing we're covering, but it's something that's good to know. So just try your best on this one. Try to apply the exact same line of reasoning here. So find the midpoint. There's your midpoint. Calculate the slope, rise over run. Maybe use some graph paper if you're really stuck, but get the slope. And then when you use point slope form, you're going to go y minus this y value equals opposite reciprocal of your slope here. Flip it over, make it opposite, and then x minus this x value from here. Okay? All right. So for 16, all you want to do is graph the points you're given. So it says, consider the segment AB that has this A value, this B value, and find the equation of the perpendicular bisector first, and then pick a point on the perpendicular bisector and prove that it's equidistant to points A and B. So we'll do this one together. We can consider this part of our lecture, I guess. We've got 4, -1. There's point A. -4, +3. There's point B. And let's look at this segment. If we're very careful when drawing this. I wasn't very careful. I kind of messed mine up. But if you are very careful, you'll notice that they cross at the point 0, 1. They cross the y-axis at 0, 1. And so what's the slope of AB? Well, let's see. Down 4 over 8. So -4 rise, 8 run. You get -1/2. So what does that mean for my perpendicular bisector? Here's perpendicular bisector. So this line here must have, let's call this line L. The slope of L must be +2. 2 is the opposite reciprocal of -1/2. And so that, therefore, the equation of line L is y equals 2x plus 1. Notice I did not have to use point slope form here. I didn't have to use the more difficult point slope form because it crossed the y-axis at a nice, obvious spot of 1. So there we go. There's our equation. Now, what the question says is pick a point that's on this line, okay, and prove that it's equidistant to points A and B. So let's pick a point. What's the point that's on this? Well, we follow the slope of up 2 over 1. Let's make our life easy. Let's pick this point here. So this is the point 1, 3. Now we want to show that this point that we just picked kind of a random point, is it really equidistant to point B and point A? Well, luckily, it's a flat line to B, so this distance is actually very easy to find. It's just 1, 2, 3, 4, 5. So let's call this point P, I guess. So from P to B is 5 units. How long is it from P to A? Well, now we got to use Pythagorean theorem or distance formula. Let's do distance formula. The distance from P to A, use a distance formula that we derive. It's, this is, again, A is 4, negative 1. So you go 4 minus 1 squared plus 3 minus negative 1 squared, all into the square root. And this is 9 plus 16. Well, let me show the intermediate step here. 3 squared plus 4 squared, which is 25. Lo and behold, PA is also 5. So what we did was we picked a point on the line, and it turns out that's the exact same distance from B as it is from A. All right, so hopefully you followed that well enough. That is so that just is an example of how, one, you can find the equation of the perpendicular bisector, and then two, it shows that any point we pick on the perpendicular bisector is the same distance away from A and B. 17, let's just skip 17. You don't have to do 17. It's basically generalizing this formula. You'd end up with a whole bunch of big formulas that I think it's better, for now, just to keep it simple. Just do it with the numbers. Okay, so we are got a few more here. So the rest are actually quite a bit easier. So to do a reflection, all you do is you reflect perpendicular to the line. So look at the slope of L here. The slope is negative 2, so it's down 2 over 1. So to do the perpendicular, you just go a slope of 1/2. So let's see, hopefully this makes sense to you. A would reflect like this. There's A prime. Do you see how that's perpendicular? So if you do it right, this should be perpendicular, and these should be the same size. How about C? There you go. There's C prime. Again, those are perpendicular. Those are the same size. And then B, a little bit trickier. Just follow that slope of 1/2. And there we go. So this is a nice mirror image now of that original point. Okay, let's do one more together. The slope here is positive 2. See how it's up 2 over 1 slope? I'm sorry, I misspoke. It's 3. My apologies. If you follow this line, it's up 3 over 1. So now the path I have to follow is a slope of negative 1/3. If we follow that, we get point A prime there. B, same thing. Follow this path. B prime. Now C is on this side, so we have to just reflect over to that side. Again, follow a slope of negative 1/3, and there's C prime. So you get this kind of neat looking reflection. So you can hopefully you can visualize that flipping over the line and reflecting. Okay. So there's a few more for you to practice. Just a tip here on something like this. If your point is already on the line, he's going to stay put. He's not going to go anywhere. In fact, let's just do this one real quick. I don't want there to be any confusion on this one. So the slope of this line is 2. So this is going to go like that. the slope is negative 1/2. B stays where he is, and then C follows the same kind of path that A did, and so my reflection, so this point is B and it's also B prime. So it reflected onto itself. There's my, okay, so hope that makes sense. 19 is the exact same thing. Hey, I'm just recording for my remote class here. It's all good. Okay, so, we're going to skip these two. Skip those two problems. And, all right, so the last couple here of these are just going to be, you draw the polygon, and then you reflect it over the given line. So here it's, you have to draw P at negative 2, 3. Here's B. Q's at 4, 3. R is at negative 1, 0. S is at negative 4, 1. So there's my polygon. And we have to now reflect it over the x-axis, it says. So reflect over the x-axis. So that's this. This is the x-axis down here. And so let's do it point by point. Q is going to reflect over like this. R is on the line of reflection, so he stays where he is. So R and R prime are the same point. P is 3 units away. It's going to jump over the line. There's P prime. And then S jumps over the line. There's S prime. Okay. So, again, if you do it right, you should see a nice mirror image of your original shape. So that's all you got to do on all these. So this time the line, the reflection line is y equals negative x. That's this line. So just make sure you're carefully reflect every point over that line. Same thing here. The line y equals x is going to be this diagonal line. So again, you just got to carefully reflect each point over that. And then 25 is reflecting over the y-axis. So you're reflecting over that vertical y-axis. Okay. And then the last thing we got to cover here is what if we, I guess kind of the second to last thing, but what if we want to find the line of reflection given a pair of points? So like, for example here, if A is at negative 2, 2, and A prime is at 4, 0, how do I know what the line of reflection is? Well, you're in luck if you were able to understand that whole perpendicular bisector thing, because that's exactly what this is. So there's A prime. The line of reflection goes through the midpoint. So there's the midpoint. And it has an opposite reciprocal slope. So the slope we see here is negative 1/3, down 1/3. And so my line of reflection right here is perpendicular, and it chops A prime in half. So now I tried to be very careful drawing this line, because a lot of the time the line's just going to end up crossing the y-axis at a nice known point. So like, for example, on this one, I don't have to use point slope form, because I can see the slope is 3, positive 3 slope, up 3 over 1 slope, and then the y-intercept is -2. And so my equation would be y equals 3x minus 2. That's your old, that's using the old y equals mx plus b idea. So same thing on part B, C, and D. You just, if you're struggling with the equation, let me know. At the very start, though, just try drawing the points. Draw point A prime, whatever, and then look at the midpoint, and then try your best to figure out the slope that would be perpendicular. So you got to try to find that opposite reciprocal slope. You can, we'll just skip 27. Don't worry about 27. Almost done, I promise. 28 is draw the line of reflection and find its equation. So again, more equations of lines. A lot of times you can kind of just see the line of reflection, kind of eyeball it, and then you just got to make sure you draw it in nice and careful. So the line of reflection is going to be remember, it's the perpendicular bisector of this guy, of AA prime. It's also the perpendicular bisector of BB prime and of CC prime. So really all you got to actually do is figure out all the midpoints. So that dot right there is halfway between A and A prime. B is going to be a little bit trickier, but I can kind of see from B to B prime, I got to go, let's see, down 3, 6, 8. I got to go down 8, left 4. So to go halfway, I go down 4 over 2. That's halfway between B and B prime. How about C and C prime? Down 4 over 2, so halfway is just down 2 over 1. Hopefully that just visually looks good to you. There's my line of reflection. And we're pretty happy because it crossed the y-axis at a nice point. So I can see my slope here is -1/2. And my y-intercept is -1. So the equation is y equals -1/2 x minus 1. So there's my line equation. Okay, so let's move on. So there's a few more of those. So basically you just follow this exact same process on all of these. Let's do one more just so you have an extra example. We'll do C together. I'm going to do it a little bit faster though. So between C and C prime, there's the midpoint. Between A and A prime, there's the midpoint, halfway. B and B prime, again, that's kind of tricky, but hey, I actually already have 2 points. So that's really all I need, really, is just these 2 points. So if I draw this in, there's my line of reflection. What's the equation? Well, the slope is 1, and the y-intercept is 2, so my equation would be y equals x plus 2. And there you go. There's your line of reflection equation. All right, so 29 is just a couple more of those. That makes sense. And all right, the last couple questions here, guys, are an application of reflection. Okay, these are actually pretty easy questions. I know they're word problems, but they're not too bad, I promise. So George is playing mini golf. The ball is at point A and the hole is at point B. Where should he aim his shot to bounce it off the wall and into the hole? So the trick here is to basically what he wants to do. He wants to bounce it off this wall, somewhere around here, and have it hit in point B. And so the idea with reflection is if I actually reflect B over this line here, over this wall, let's see, he's 4 units away. So I go over 4 over 4. So call this B prime. And now what I want to do is just aim right at point B prime. So if I aim there, the way reflections work, it's going to go towards that and then bounce off the wall and hit there. So let's see, how far is it to get from, or what I want to do is very carefully draw this line. If I use a ruler, I don't have a ruler handy, but you can use one. I'm just going to count off. So I'm going to go, let's see, 2, 4, 6, 8, 10. So right 10, up 5. That means the slope of this is 1/2. So I can just go over 2 up 1, over 2 up 1, over 2 up 1. Notice what I've done here. I have ensured that my line is going to hit point B. Now what's really going to happen though is it would bounce off this point right here. That's the answer to the question. That's where he should aim. Aim there. So basically he visualizes this, he aims there, and the ball should go bounce and then land in the hole. And that's because these angles would actually be the same size. That's one of the properties of reflections that we'll get into that later. So 31 is going to be pretty similar. I think you can try to figure that one out. Basically, you want to get from P to the conveyor belt and then to Q to drop off the widgets and gadgets. And so you're going to want to reflect point Q over, aim for it like that, and then that point where you cross the conveyor belt, that's going to be where you want to aim for minimizing your total distance traveled by the cart. 32 is pretty similar. You might involve, it's not going to be a nice whole number, but you can try to figure out what point exactly on this you want to aim the laser. Again, these questions are all very similar to the golf one, so just try to apply the exact same logic to these ones. Lastly, we're going to skip 34, 35, and 36. Those are all skips. That being said, if you want to go above and beyond and do those for extra credit, certainly feel free. If you just email me and let me know, hey, I want to do these problems for extra credit to boost my grade, and I'll definitely say yes. I'll give you the go ahead, but just want to make sure that you're not overloading yourself. So, okay. Anyway, guys, I hope that all makes sense. Yeah, contact me if you have any questions, if anything's confusing. So I'll talk to you later.